All right, so I got it. Quick, what were the new derivative rules that we have? So if we have a base A log or a base A exponential. So we want to differentiate a base A exponential of u with respect to x, where u is just, some function of x, so this is our chain ruleified version. What do we get?
Natural log A
Good.
A to the u times.
Good, so we get the normal, what we'd expect as if it were an e. A to the u times u prime, but we have to multiply by a log a, right, natural log a. Okay. And then derivative with respect to x of the base a log of u is what? So it's normal, right? Which would be, if that were a natural log, we would just expect a u prime over a u. But what's different on this one? Where's it go on this one? Bottom. Yeah, so we're just, and here's a way to remember that. Exponentials are easier than logs, right? Multiplying is easier than dividing, right? So that's how you can remember where that log a goes, right? Okay, so we did a bunch of examples yesterday on the exponential ones, but we didn't do any, as I recall, we didn't do any log ones. So let's have a quick look at these. And there's some good. Okay. What can we do there? We can be tricky. Right, we always, when we're dealing with logs, we always want to see if we can invoke some properties of logs to make things easier. Now, let me remind you also that even though we wrote all of our properties of logs in terms of natural log, all a natural log is a base E log, and regardless of the base, the rules are the same. We have properties of logs. So we could power through this and take both of these separately, but can we make it easier? What's the property that might be useful here? The log of a product equals the sum of the logs. Everybody see that? So the log of A times B equals log A plus log B. So how could I compress that?
Log base 7 of x to the 7th.
Yeah, of x squared times x to the 5th, right? It's just x to the 7th. Way easier. Agree? Okay, which is just equal to, yeah, base 7 log of x to the 7th. And what else can I do to make that super easy?
7 log x.
Yeah.
7 log base x.
Right.
7 log base 7.
If I have the log of a power, I can just bring the exponent out front. Okay? So we end up with 7 times base 7 log of x. And now that could be easier, right? So now we end up, if that's y prime equals, we leave the 7 out front. What's the base 7 log of, or the derivative of the base 7 log of x? derivative of the base A log of u, isn't that just u prime over u divided by log A? That's the log A goes in the bottom. Right, so what's u prime? U is x this time, 1. So we're going to get a 1 over x, and then we're going to get a log 7, right? Everybody agree? So we just end up with 7 over log 7x is our answer. We could have made that a lot harder. I mean, we could have just differentiated both of those separately. And we could, I don't want to waste the time to show you, but we could have done it. If I had not used any of my properties of logs, I would have had, just think about the u prime over u part. We would have gotten a 2x over x squared. Well, that's just simplifies the 2 over x, doesn't it? Right? And then we would have had the log 7 on the bottom. And here we would have had a 5x to the 4th over x to the 5th, which is a 4x. Agreed? With a log 7 on the bottom. And if I add all those up, 2 plus 5 is 7, right? Common denominator would have been that. It would have worked. It's just easier. Okay? Another one. How about this guy? Base 5 log of e to the 3x squared minus 7x. Say it again. Can't do that. Oh, I see what you're saying. I see what you're saying. I got you. Yeah, there's another way to think about that. So, suggestion, I see what you're saying. Yeah, the suggestion is use this. You could do it that way. The suggestion is use this, the natural log of a to the b equals b log a. So you could bring that stuff out front. That works. Okay, there's another way to do this, though. There's another way to do this, too. Think of the property, if I have a base 5 log of something, what's my property I use for that?
All that over the natural log of 5.
Yeah, if I have the base A log of u, isn't that just natural log u over natural log a, right? You get the natural log of the argument divided by the natural log of the base, right? Why is that helpful? Well, look what that does. I get the natural log of that okay, but what's the natural log of e to anything? Well, natural log of e would be 1. But if I have the base e log of a base e exponential,
It's just the exponential.
right, they cancel. Everybody agree? I mean, it's the exponent, right? They cancel because that's their job. They're inverses. So these guys would cancel on the top, just leaving me with 3x squared minus 7x. On the bottom, I've just got natural log 5, right? So that's why. Now, this is a pretty easy derivative, right? Log 5 is a constant, so I can pull the 1 over log 5 out front. Agreed? So when I calculate my y prime, I get 1 over log 5 times the derivative of the top. But man, that's easy. What's the derivative of 3x squared minus 7x? There it is. Okay. Right? So you can kind of see the moral of the story here. One moral of the story is logs, a lot of times, those properties can really make these simple. Okay. fancy properties of logs there I can use? No is correct. How come?
Some
Yeah.
there, so there's no storm, or just take out
Yeah,
all
so
the-
I can't simplify a sum, that's the bottom rung, right? So log of a sum, we're stuck with. Log of a product becomes a sum, but the log of a sum, we're stuck with that. So that's U then, isn't it, right? We just got, all this is straight application of the derivative rule for this one. So what's that gonna give me then? So I have a derivative of a base 5 log. I get a normal answer, but what's the one additional thing? It's different. What do you think? But what everybody, just real quick, everybody close those up. We'll do like a couple more examples and then go, but I feel like if you don't get this now, it's just gonna be harder to figure out on your own. So it's time well spent. Just take a second and focus. What's my rule? So I got log A on the bottom, and then regular U prime over U, right? So, natural log 5, now what? What's U prime? Yep, 3x squared over, that's it. Nothing else I can do. Okay. Let's get- okay, what about? That's probably good. Let's do that. Okay, what rule am I going to use here? Okay. Any other suggestions?
Four out front.
Okay. Would I want to use quotient rule? It's really not a quotient, right? When we say quotient rule, that means a quotient of functions, right? Is the top a function? No. Nope, it's constant. So we definitely want to rewrite this as pi times log, base 3 log of x to the 4th to the negative 1, okay? So how many layers are there to that function now?
2. The log and the x.
Okay, so I'd say 3 then, right? Because you've got but you missed with the outside, we got double hand to the negative 1, right? Is the outside one. Then inside that, we've got a log of hand. And then inside that, we've got an x to the 4th, right? Okay, so if I want to differentiate this, then I'm going to end up with a negative pi times hand to the what? What's the derivative of hand to the negative 1?
Hand to the negative 2.
Right, negative hand to the negative 2. Oh, and there was one suggestion too. Yeah, why not? I could pull that 4 out in front of the log if I wanted, at any time, right? So when I differentiate what's inside, let's rewrite that as 4 base 3 log of x, right? Okay, and that makes it really just 2 layers, right? So now if I multiply by log of what's inside, what's that going to be? Where's 4 go? Where's 4 go? I'm differentiating all that stuff. You see why the 4 is stuck in there, though? I get a sense, maybe, are you wondering why that we can't just pull the 4 out in front of the whole thing?
Because it's really into power.
Yeah, because it's inside the power, isn't it? That 4, if we put it out front like that, which we can do, it's still inside the original power, right? It's part of hand, okay? When I differentiate what's inside, though, if I'm just differentiating just that stuff, well, yeah, now it's a constant in that derivative, so we'll leave it out front. And then I've just got the derivative of base 3 log of x. So that's just going to be u prime over u, so I'm going to get a 1 on the top and an x on the bottom. And where does my natural log 3 go? Bottom. Okay, so then we're done with the calculus, but we got to clean this up. So what goes on top and what goes on bottom? So on top, we've just got, that's going down, right?
Yeah, and take the
That's
4 out.
top, so negative 4 pi. On the bottom, I'm going to get log 3 and x,
2 log base 3x.
and,
Square root minus the x.
yeah, and then all that stuff, right?
But we can take the 4 out. of
We
the square root.
can, you're right, so we get a 4 log, base 3 log of x squared, and I could write that as 4 squared times base 3 log of x squared. Everybody see that? So we could actually then write this as, I'll add 2 more steps here. So we've got log 3, this stuff right here, that's going to become a 16. Agreed? And then I could reduce this to a 4 on the bottom. What about that 2? Could I bring that 2 out in front of the log?
Because it's not the whole log.
Yeah. Right? I can't do that because it's the whole quantity that's being squared. If it were the log of x squared, then I could. See the difference? So then if I wanted to write my best version of that, I'd get a negative pi over 4 log 3 times base 3 log of x squared. And you could write that as natural log x over natural log 3 if you wanted to. And if I did that, this is sort of optional. Everybody see I'm going to get a negative pi log 3 over 4 natural log x squared.
Where did the X go?
Where did the x go? We lost it, didn't we? Yeah, it should be an x in the bottom too. Yeah. And you see, that's how, you could get it that way if you wanted to also. That's how I'd probably write it. I really don't like to write bases other than, it's nice to always write things in terms of natural logs. So does everybody see how I got there? That whole thing would just be, this whole thing right here, I could just write as natural log x over natural log 3. I could square it, so I could square each one individually. Then flip and multiply by the natural log 3 squared. And I cancel a log 3 with one of the log 3's on the top. Everybody see that? Okay. Maybe just one more. Okay, yeah, I know why I want to do this one. Yeah, I had one more I wanted to do. The last one, promise. So if I give you y equals 3 times the base 6 log of x squared plus 1, so we can't simplify. I want to know what y double prime equals. And just kind of also something, we're kind of in this section in the calc book where this is the part where you have to learn how to do base A, derivatives of base A logs. But like if I were doing this in physics, I would have immediately rewritten that as natural log of that function divided by natural log of 6 and just pulled the natural log 6 out front. You get that too? You see how that works? Okay. And then it's an easier function to deal with from the very beginning. Okay. So what about this one then?
Just pull it through out.
Okay, pull the thread. In fact, let's do what I just said. Why not? Why not just rewrite the original function? Because we're going to take the second derivative of it anyway. And why not just do this? Why not just write this as 3 over natural log 6 times natural log of x squared plus 1. Then I'll just leave that natural log 6 out in front of the constant. And we just leave it out in front the whole time, right? For both derivatives. Okay? You have to do it that way? No, I mean, I sure would. So what's y prime going to be then? So we've got our constant. And then this is an easy one now, right? Natural log derivatives are a piece of cake. What's that going to be?
That's just, right, no. It's gonna take that, it's gonna be 1 over whatever is in the natural log.
Well, derivative of natural log u is just u prime over u.
Times the rest of it.
So I get 2x over x squared plus 1. So there's my first derivative. And now if I do the second derivative, look what I got. I got this constant out front times quotient rule, right? Does that make sense? We probably don't need to do it. I will if you want me to. I'll let you work too if you'd rather do that.
That's-
Okay. Anybody want to go through it? I'm sure deep down you probably do.
Go for it.
Okay, so if you wanted to start working, you can, but I'll go through it. Times, so I get my low D high minus high D low over low squared gives me, so I get 2x squared, so 2 minus 4x squared. No, 2 minus 2x squared. Right. I just factor 2 out. Now we got a 3 factor. Okay. Make sense? Okay, so if you got questions, bring them up. Man, we pack a lot of math in a short period of time in here, don't we?